Hello, my name is Nartatez. I am a senior manufacturing engineer at Cal Poly San Luis Obispo, and this is my senior project on the design of a battery tray and manufacturing process for SMG metal fab. The agenda for today's presentation will go as follows. We will begin with a company background, followed by a problem statement, project constraints, expected deliverables, methodology on how I went about solving my project, and conclusion. A little bit about the company background for SMG Metal Fab, as they are located locally in Como, California. That's about 20 minutes south of San Luis Obispo. Their main industry sector is structural steel. So what they do is they make things such as spiral staircases, handrails, guardrails, wrought iron gates, things of that nature. And what they're looking to do is to enter the off-road market because of their abilities. They want to create a few parts and begin selling them online on a make-to-order basis. So the problem statement is to design an off-road battery tray and manufacturing process to consistently produce this battery tray of a desired quality and analyze costs based on material and labor to suggest a selling price. Now, what a battery tray is what it does is for when you're off-roading, you do experience extreme angles and extreme vibration, and what the battery tray is designed to do is to keep this battery stationary and intact, so that doesn't come loose or disconnect from the vehicle. Some of the project constraints given by SMG Metal Fab is that the cost of production is less than $40. This is so that way the selling price afterwards can be competitive compared to what's currently out on the market right now, which usually range from about anywhere from $45 to $100. The total production time must be less than 2 hours. This is because SMG will not be creating these battery trays and storing them in inventory. What they'll do is when they get the order, they will actually begin making the product as soon as possible, and they would like to get that out within 1 week. Another constraint is that we must use common welding shop equipment. They don't want to have to go out and buy more equipment just to produce this product. And lastly, the use of a CNC torque table is preferred. SMG Metal Fab has actually purchased one of these machines, and they bought it for use in their structural steel sector, but currently doesn't get much use, so they'd like to use it in the motorsport sector to try to get some return on investment on that. So expected deliverables are to design a battery tray to accommodate an Odyssey PC1200 MGT battery. This is a not very commonly used battery in vehicles. However, in off-road vehicles such as side-by-sides and sand rails, things of that nature, trophy trucks, it is very commonly used because of its size and versatility, and as well as the cranking power that it puts out. Another deliverable is to design the manufacturing process, as we talked about, for the battery tray. This will include documentation that has operation sheets, routing sheets, and then cost analysis. The documentation is so that way this part can be consistently made amongst various operators. So the first step in creating this battery tray is to do a CAD model of the battery that we're actually be working with, and this is so I could have dimensions at my computer while designing, and also just to have a rough idea of what the part looks like. Next, working with SMG, we designed a model as far as form and function goes. As you can see here, the tray is the gray part on the bottom. The blue part is the actual battery, and this gold part is the top strap that will limit the battery. The battery tray and strap do resist the movement of the battery, and also to use the freedom and keep it from not falling around everywhere while you are off-roading. So after we designed the form, we had to go through and decide what kind of material we use. So I created this material selection decision matrix, as you can see here on the left. Custom requirements, which include rigidity, lightweight, corrosion resistant, cheaper than $45, easy to clean, and aesthetically pleasing. And then next column is the weight, which is the weight factor that each one of these categories has on the final product. And then the next 5 rows are possible materials that we could use, mainly focusing on aluminum, stainless steel, and steel. I did put plastic and wood in here just to kind of see how they would score. Unfortunately, plastic did score the highest, but S&G did not have the shop capabilities to process plastic, and then wood obviously scored the lowest, so that was not a consideration. Aluminum and stainless steel did tie, and with that, we came to decide on 5052 832 aluminum. It's a 90 thousandths thickness sheet metal. This material is corrosion resistant. It's easily bendable with tight radiuses. Pretty cheap. It's easily weldable, and it has no finishing steps required, as opposed to if we were to use plain steel, we would have to do some kind of finishing step as far as cleaning and powder coating, so that way it wouldn't rust. So the next step was to design the process and how to actually make this battery tray. On the left is a CAD rendering of the plate that would be cut out on the Torchmate table, which you can see here on the right. From the CAD software used was a Torchmate specific software. The G-code was created using the image here on the left. Setup time for that was estimated to be about 2 minutes with a cycle time of 2 minutes. I'm sorry, 10 minutes. Next step was to put dimple dies in on the 12 circles you see on the plate. These are more aesthetics, although there is some research that has shown that dimpling sheet metal could actually add to its rigidity. That was out of the scope for this project, but it's a very common practice to do amongst off-roaders just for the aesthetics, as well as maybe quite possibly some of the rigidity function. But the setup time for this is a simple setup, about 1 minute, and cycle time is about 25 because of the 12 holes and changing of dies, and the press used was actually a ball jack press similar to the one depicted here, so it's a little bit of a manual process. The next step was to bend the metal in a press brake to the desired shape. This process was a little challenging because of bending all 4 sides. Obviously, once you make the bends on 2 sides, then when you go to bend the other side, it's going to kind of buff into your press a little bit. But luckily, S&G did have different size dies for the press brake, and there's also some very small bends in there. This was the most challenging step throughout the process, but we were able to get everything written down clearly on the operation sheets as far as what areas of the tray to bend first and how to go about doing that. And then the last process was to weld all the corner joints to give it some rigidity. So next, after the process was designed and laid out and documented, we went ahead and did a cost analysis just based on material and labor. Didn't want to include things such as indirect production costs just because it was hard to get hard fact numbers from the S&G Metal Fab. They weren't really willing to come up with disclosures on how much time and money was spent on things such as electricity or cost of machinery, so just kept it to material and labor. As you can see, the direct material, including the aluminum for the sheet, the hardware, which includes nuts and bolts to actually attach the top strap to the bottom strap, filler rod to weld, and then a rework / scrap factor of 1.04 came out to $7.03. Direct labor based on a $15 an hour operator at 1.75 hours, and a rework factor of 1.02 came up with a figure of $26.78 for a grand total of $33.81. So, in conclusion, I talked about some of the challenges. Obviously, the cutting process was done, and that does work, but we still need to do some of the other processes, and we'll have to create a first article tag. The cost was underneath the specified $40, and the time was underneath the 2 hours specified. So that's it for the presentation. Thank you.